Hello everyone, welcome to Algebra 1 with Miss Betsy. I'm glad you're along with us today for the ride as we are continuing our progression of junior high school Algebra 1. And what we're going to be talking about today, we're going to begin dealing with relations, functions, and graphs, or it's an introduction into linear algebra. And I think you'll find a lot of this enjoyable. For those of you who are following along with me, I'm using as my text Algebra 1 for Christian Schools. It's published by Bob Jones University Press. I'm using the second edition. I'm in Chapter 6, Section 6.1, on page 218. Material is directly relevant to anything about linear equations, functions, relations, regardless of what text you're using. Now, before we go ahead and get started, can you tell me what it is that you would call a fly who has no wings? Well, you would call him a walk. Without his wings, that's the only thing he can do is walk to where he's going. So, some of you have wondered where exactly I'm coming from. Because I've chosen to make a very rough attempt at a sketch of the map of Texas, I'll let you know that we're coming to you somewhere from the great state of Texas. I have sketched in the rough location of 3 of our cities. We have Dallas, San Antonio, and Houston. And I've drawn a grid on here that would be representative of the old paper maps that you used to use before you had internet access constantly. You had the smartphones, you had MapQuest, you had the GPS units that you would put in your car that tell you turn left at the next stoplight and then turn right and drive into the lake when you would navigate without any of those electronic aids. You see that what we have down along the horizontal portion of this graph, we have A, B, C, and D, and then going vertically, we have numbers 1 through 6. And this is also very similar to the type of grid system that many of you have used or still using when you play the old game Battleship. And you say B1 and you either have a miss or you've hit your sub, and after you hit it enough times you sink it. But what these mapping things did, you use a combination of a letter and a number to locate a specific region in this map. For example, if you would say B2, you go over to the B, go up to the 2, and this whole area right in here is represented by the expression B2. This is what we would actually call an ordered pair. And an ordered pair is a set of 2 numbers in which the order is important. You have to say the B first, and then you say the 2. And an ordered pair is just generically represented by X comma Y inside parentheses. And what ordered pairs do is they locate specifically, in this case of a map, a specific region on that map. So if I wanted to say what area, where would you find Dallas on the map? Well, you'd see that Dallas is in region C4 of the map. ABC is the intersection of C and 4. And the location C4 doesn't tell us exactly where Dallas is. It just tells us that it's somewhere in this rectangular area of space. Similarly, you would find Houston at the location D3. And all 3 of these expressions here would be considered ordered pairs. First you have a B, then a 2, a C, a 4, and a D, and a 3. And ordered pair is something that you have to have a total complete understanding of and realize that ordered pairs, it's a pair of numbers in which the order is important. Not only is order important, it's crucial. And I'll show you why in just a second. Here, the two members, or two elements of our ordered pair, one of those are alphabetic characters. The second one is a numeric character. So even, here, even if you got it out of order and said 2b, you could still come up with the same area here, wouldn't you? You'd go over 2 and come up b, and you'd still get the same region of your graph, but with an actual ordered pair where you have only numbers, the order it's essential that you get the order right. Now, hang with me for about 2 minutes and I'll illustrate that to you. Second thing that I wanted to talk about that is vocabulary is what they call a Cartesian product. The Cartesian product is represented by this really weird looking expression, and it says S cross T. And that really is an X, but it's S cross T. And what the Cartesian product is it takes two sets and it matches all of those elements together, puts them together in a set of ordered pairs. The first set that we would have here, using our map of Texas, is represented with the alphabetic characters A, B, C, and D. The second set, set T, is indicated by the numeric characters 1, 2, 3, 4, 5, and 6. What the Cartesian product is it's the set of every possible combination of one element from S and one element from T, but S has to be the first element in each ordered pair. So here I have A1, A2, A3, A4, A5, A6, B1, B2, B3, B4, B5, B6, C, 1, 2, 3, 4, 5, 6, and D, 1, 2, 3, 4, 5, 6. So when you have the Cartesian product, you have a specific grouping of ordered pairs that lets you identify a whole region of space. So the cross product here would be indicated, or the Cartesian product here would be indicated like this. You would have A1, the ordered pair A2, A3, and so forth, until we had put together the representation for every single one of these regions on the map. And that's what they call a Cartesian product. Now there's a special type of a cross product, a special type of a Cartesian product, and that's what happens, that's what you get when you take the set of all real numbers and you pair that up with, yet again, the set of all real numbers, and you get a particular, what happens here is you've got every possible point that's located on a plane. And this is where we get our Cartesian coordinate system. It's the Cartesian coordinate system. And you also have the Cartesian plane. So today there's a lot of vocabulary that you're learning. I'm trying to keep this in the screen and me in the screen at the same time. Cartesian coordinate system, Cartesian plane, Cartesian coordinates, all of those are named after the famous mathematician René Descartes, who several hundred years ago was the first person to see that there was a connection between points in a plane in algebra, so these things have been named after him. Let me go ahead and show you what a Cartesian coordinate system is. And you're going to be working with Cartesian coordinate system and Cartesian plane for all of the rest of your time in algebra. No, you're all crying because I'm erasing this beautiful picture of Texas. Actually, it's probably tears of delight that you don't have to look at that anymore. So, let's go ahead and draw Cartesian plane. It's made of two lines, perpendicular lines, and they intersect. The point that they're intersecting here is called the origin. It's represented by the point 0, 0. The horizontal line is called the x-axis. The vertical line is called the y-axis. What we have here really is, you can think of this as taking a number line, negative numbers to the left, positive numbers to the right, and a vertical thermometer, positive degrees to the top, negative degrees to the bottom, and the point here at which these two lines cross is the point where the values are both 0. So to the right, on the number line, on the x-axis, you have positive numbers. To the top, on the y-axis, you have positive numbers. To the left on the x is where you have your negative numbers. And to the bottom, on your y, you have negative numbers as well. And what you're able to do by using an ordered pair, you can specifically and precisely locate any individual point, any place on the whole plane that is in space. And what's different about the Cartesian coordinate system and that map that we saw earlier, the map just gave us regions. It said, okay, B4. Someplace in this square here is where the city of San Antonio is located. Here, we identify one particular, very specific, very unique point in the whole plane. So we have ordered pairs. Ordered pairs. And we represent those in general. In parentheses, we have x, comma, y. So what do you think that might tell us? Well, if our vertical axis is the y-axis, and if our horizontal axis is the x-axis, that's exactly where we're getting these numbers from. When you have an ordered pair, for example, one represented by 1, 2. The 1 in the place of the x means that we're going to go to our horizontal axis, to our x-axis, to the point 1, and our 2 is the point on the y-axis. So we're going to find the intersection of 1 and 2. Put a little dot at the point where those would intersect, and this is the point, the unique point that is identified by the ordered pair 1, 2. Over 1, up 2. Now remember, I've been saying it's an ordered pair, order is essential. What would happen if we wanted to graph the ordered pair 2, 1? It's going to be different because our first number represents the location on the x-axis. 1, 2, and the y is 1. So you can see illustrated very clearly here for you that the order is absolutely essential. If you get the x's and y's out of sync, you've got two totally different locations represented here. You have an x coordinate and you have a y coordinate, and they have a particular name. Let me write these down for you. I know that you get so tired of this vocabulary, but that's just really sort of part of what you have to deal with. The x-coordinate is the first number in an ordered pair, and you need to know that that's a fancy word they call the abscissa, and the y-coordinate they call the ordinate. It's just vocabulary that you have to understand, because you'll have some problems on a test, or problems particularly on a standardized test, where they might tell you the ordinate is 2 and the abscissa is 3. Well, if you just revert to thinking about locating a point on a plane, you might just use the ordered pair 2, 3. Well, would that be true? No, they told you the ordinate was 2 and the abscissa is 3. So you have to know ordered pairs. X comes first, y comes second, and that the x-coordinate is called the abscissa and the y-coordinate is called the ordinate. Nothing I can do to make this even remotely fun. You just have to memorize it. The points intersect at the origin. Another thing that you're going to notice about the coordinate plane here is that with our intersecting horizontal and vertical axes, we've divided our plane up into 4 regions, and these are what they call quadrants, and they have names, and they start here in the upper right hand corner. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. And they are identified using Roman numerals, and they start in the upper right hand corner, go counterclockwise. And all of the ordered pairs within one particular region share something in common. What are the signs going to be for all of the ordered pairs here? Well, look, we're going from 0 to the positive direction, 0 to the positive direction. So all of the ordered pairs, the x value is going to be positive, and the y value is going to be positive in the first coordinate. What about our x values here? These are all negative values for that first member, first element of our ordered pair. But our y values are all positive. In quadrant 3, what do we have? Both the x's and the y's have negative values. And in quadrant 4, the x value is positive and the y value is negative. You just see the pattern catty-corner from each other. The signs of the ordered pairs are opposite. Don't worry about trying to memorize any of this, because you can easily figure out, oh, all of the x values here are positive. Oh, all of the y values here are negative. But you do need to know quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So now let's go ahead and say, how are we going to do what they say, plot a point? Plotting a point is the same as graphing an ordered pair. And let's think for a minute. If I say graph 2 on the number line, what do you do? On the number line, the number line is just this horizontal line here. The further you get to the right, the larger the number. The further you get to the left, the smaller the number. And this would be all you have to do to graph the point 2 on the number line, because there's just one coordinate. What we're going to do now, thus, is to say plot an ordered pair on this Cartesian coordinate system. Or we might say locate the point, graph the ordered pair. But let's say locate the point -1, 2. Our first number in the ordered pair is the x-coordinate. It's also referred to as the abscissa. So what we're going to do is look on the horizontal axis until we find the location -1. Our y-coordinate is a 2. Because it's positive, we're actually moving up 2 units. So we can start at -1, move 2 units up, and we have identified, we have plotted the ordered pair -1, 2. And then you want to go ahead and identify that label, that point, with the ordered pair. What if we said plot 3, -3? The ordered pair 3, -3. The first number is on our x-axis, +3. The second number, -3, is on our y-axis. We're looking for the intersection of this point. 3 and -3. I've just totally erased that. But you can also think we'll start at our x coordinate, which is +3, and we're going to move down 1, 2, 3 units because we're going to move in a negative direction on the y-axis. We're going to use that idea of counting up, right, left, down to help us graph actual lines on this Cartesian coordinate system. That's really about all that we're doing in section 6.1, and I took quite a lot of time to it because they have a lot of teaching that they're doing in this section. They're just trying to get you accustomed to the idea of locating points on a coordinate system. If you get stuck with understanding what's going on, go back and look at your book, shoot me a text. I think you'll find it pretty straightforward and enjoyable as you work with it, and I'll see you next time.